Good day, grade 9 student. Welcome to Bamboo Telescuela. This is your school on air in Mathematics 9. It's a pleasure to be with you all at this time of this day. I am Jennifer A. Quintero from Kawayan City National High School, Maine, your math teacher for today. Make sure to have with you your module, ball pen, and math notebook. And go to comfortable place and prepare yourself to listen for today as you tune in to DWND-FM, DWDY-AM, and CMD Cable Vision. You can also watch us streaming live at SDO Kawayan City Facebook page. For today's lesson, we are going to first identify the different theorems of special right triangles, and second, use the theorems in a special right triangle to solve sides of a right triangle. After going through this module, you are expected to apply the different theorems of special right triangles to solve sides of a right triangle. So please listen carefully and be mindful of the topics that we are going to discuss. In the previous topic, you have already learned how similar triangles are formed if an altitude of a right triangle is drawn from the right angle to the hypotenuse. Now, it is time to learn the different ways of dealing with unknown sides of a right triangle. The usual way of finding unknown sides of a right triangle is through the Pythagorean Theorem, which is a raised to 2 plus b raised to 2 equals c raised to 2. Note that in order to use the Pythagorean Theorem, at least two measures of the sides of the right triangle should be given. But there are kinds of right triangles which one side given is enough to find the other remaining sides. These right triangles are often referred to as special right triangles. The relationship between the sides are stated in the theorems alongside with other conditions. Let us proceed in discussing the two special right triangles, which are the isosceles right triangle or 45-45-90 triangle and the 30-60-90 triangle. The isosceles right triangle 45-45-90. It states that in an isosceles right triangle, the length of the hypotenuse is equal to the length of the leg times square root of 2. Proof. Consider the right triangle on the screen. Note that it is an isosceles right triangle. Since it is a right triangle, then we can express the sides in terms of the Pythagorean Theorem. From the figure, with the use of the Pythagorean Theorem, so we can have now h raised to 2 equals y raised to 2 plus y raised to 2. Therefore, h raised to 2 is equal to the product of 2 and y raised to 2. After simplifying, we have h is equal to the square root of the product of 2 and y raised to 2. Finally, we have h is equal to y square root of 2. Note that these triangles should satisfy the conditions. The triangle should be isosceles and at the same time right. Variables are used in this case, but these variables can be replaced with numbers. The relationship would still be the same if actual numbers are used instead of variables. If one of the legs is missing, how will you express it in terms of the hypotenuse? If the measure of the hypotenuse is given instead, how will you determine the length of the legs as the case of the triangle on the screen? We use the relationship given that h is equal to 8 and the formula for h is equal to x square root of 2. Therefore, deriving the formula for x, we can have now x is equal to h over square root of 2. And the result is 8 over square root of 2. Simplifying further, x is equal to 8 square root of 2 over square root of 4, and that is now equal to 8 square root of 2 over 2 since square root of 4 is equal to 2. Finally, the answer for the value of x is equal now to 4 square root of 2. Therefore, the measure of the leg of the given right triangle is 4 square root of 2. Since it is an isosceles right triangle, then the other leg measures 4 square root of 2 also. Let's have this one. Given an isosceles right triangle whose one of the legs measures 12 meters, what is the measure of the hypotenuse? Since the figure is an isosceles right triangle, then the two legs are equal. The formula in finding for the hypotenuse of isosceles right triangle is h equals leg times square root of 2. We are going to substitute the measure of the leg. Then we can have 12 multiplied by square root of 2. And the result is h is equal to 12 square root of 2. Therefore, the measure of the hypotenuse is 12 square root of 2 meters. The 30-60-90 triangle. It states that, number 1, in a 30-60-90 triangle, the length of the side opposite 30 degrees angle is 1/2 the length of the hypotenuse. Number 2, in a 30-60-90 triangle, the length of the longer leg is equal to the length of the other leg times square root of 3. Proof. Given the triangle on your screen, we have drawn NC such that measure of angle CNS is equal to 30 degrees. Therefore, triangle CNH is an equiangular triangle which is also an equilateral triangle. Since NF bisects angle CNH, it follows that it bisects CH as well. We can conclude therefore that SH is equal to 1/2 H or H over 2. Let us now consider NSH with sides NH which is equal to H and SH is equal to H over 2. By Pythagorean Theorem, H squared is equal to the quantity NS squared plus the quantity H over 2 squared. Consequently, the quantity NS squared is equal to H squared minus the quantity H over 2 squared. And therefore, NS is equal to the square root of H squared minus the quantity H over 2 squared is equal now to the square root of H squared minus the fraction H squared over 4. And it is also equal to the square root of 4H squared minus H squared all over 4. Then we can have now square root of 3h squared over 4. Finally, we have ns is equal to h square root of 3 over 2, or ns is equal to sh square root of 3. Look at the triangle on your screen. Can you say that the triangle is a 30, 60, 90? Can you justify that it is 30, 60, 90 triangle? Given the measure of one of the legs, what would be the measure of the remaining sides? From the figure, you must have noticed that C is opposite the 90-degree angle. Therefore, we conclude it's the hypotenuse, while A is opposite the 30-degree angle. If we name the third side B, we have the following relationship. A is equal to 1/2 C, then C is equal to 2A. B is equal to C square root of 3 over 2, or C is equal to 2B square root of 3 over 3. And B is equal to A square root of 3, or A is equal to B square root of 3 over 3. From the given figure, let us find the value of all unknown variables. From the given figure, let us find the value of all unknown variables. Since B is equal to 7 square root of 3, therefore, the value of A is equal to the product of 7 square root of 3 and square root of 3 over 3. And that is equal now to 7 times 3 over 3, or it is equal to 7. In finding for the value of C, we have two options. For letter A, since A is equal to 7, we have C now, and that is now equal to 2 times 7 to make it 14. Or letter B, C is equal to the product of 2 and 7 square root of 3 and square root of 3 over 3 to make it 2 times 7 times 3 over 3, and that is equal now to 14. Do you understand what was discussed to you? Congratulations, grade 9. Let us recall the different theorems involving special right triangles used to solve for the unknown side of a triangle. The isosceles right triangle, or 45, 45, 90. In an isosceles right triangle, the length of the hypotenuse is equal to the length of the leg times the square root of 2. The 30, 60, 90 triangle. For number 1, in a 30, 60, 90 triangle, the length of the side opposite 30 degrees angle is 1/2 the length of the hypotenuse. Number 2, in a 30, 60, 90 triangle, the length of the longer leg is equal to the length of the other leg times the square root of 3. Are you ready for the next level? Let us apply the theorem in solving right triangle. Find the values of x and y in the following figure. The first figure is a 30, 60, 90 triangle. To find x, it is 1/2 of the hypotenuse, which is p. The result is 3. To find y, it is 3 times the square root of 3, and that is 3 square root of 3. The second figure is a 45, 45, 90 triangle. To find x, it is hypotenuse, which is 10, times the square root of 2 over 2. The result is 5 square root of 2. Since it is an isosceles triangle whose legs are equal, therefore, the value of y is also 5 square root of 2. The third figure is another 45-45-90 triangle. Since one leg measures the square root of 2, therefore, the other leg, which is x, is also the square root of 2. To find for the value of y, multiply the value of x, which is the square root of 2 times the square root of 2, and the result is 2. So there you have the two special right triangles and their theorem. I hope that this theorem will serve as your guide in solving for the unknown sides of right triangles. With that said, I hope that you make use of this theorem because by following it, you will be able to solve problems involving right triangles. That ends our lesson. I hope you have learned and enjoyed a lot today. If you have questions and concerns, feel free to message your math teacher. And for you, dear learners, always remember this quotation. Math may not teach us how to add love or subtract hate, but it gives us hope that every problem has a solution. And put this in your mind. Hard work, honesty, if you keep at it, will get you almost anything. This has been Teacher Jen, and this is your School on Air in Mathematics 9. Stay safe and healthy. God bless.